Hello, Rickoff here. Welcome to video number 27 of Rick's Pipe Dream Magnetic Motor Generator Project Series. In this video, I will be showing the mechanical modifications which I have utilized in implementing the stator movement strategy that I explained in video number 26. My first step in this direction was to make up a new slider carriage assembly to replace the one shown here. The new carriage is 1½ inches longer than the previous carriage and 1 inch narrower. The purpose of the carriage will now be to activate the linkage rod that will be connected between the slider carriage and the pivoting stator control arm. Now that the track system has been discontinued, it is essential that the inward and outward carriage movements must be limited or stopped at predetermined locations within the slider rail channel. To accomplish this, I have mounted aluminum L-bar stock at each end of the carriage as shown here. These stop mechanisms will contact similarly constructed stops placed within and fastened to the slider channel. Each of the stop pairs will have a foam rubber padded facing as shown at the left end of the assembly to cushion impact and reduce noise as the stop pairs meet. The slider rail channel stops are shown in this photo. Holes for the mounting screws had not yet been drilled because it was necessary to first determine the precise location within the slider rail channel where these assemblies would be mounted in order to avoid contact with the screws which attach the slider rail to the 1 inch aluminum mounting bar. After determining the inward carriage travel limit, I marked the location where the inward channel stop would be located and drilled the mounting holes through the stop base, then clamped the stop to the channel and drilled down through the channel with a number 29 tap drill. The holes were then threaded using an 832 tap as shown here, and the channel stop mounted to the slider rail using number 832 roundhead stainless steel machine screws. The mounting of the outward channel stop would later be accomplished in the same manner, but first I needed to make up and attach the pivoting stator assembly and the actuating linkage rod. The pivoting stator assembly required a pivot rod mount that could be attached to the side of the aluminum slider rail mounting bar. For this, I used a 6½ inch length of the same 1 inch square aluminum extrusion stock that I had used for the slider rail mounting bar. To allow free movement of the pivot rod, I drilled the pivot rod mount to allow installation of flanged bronze bushings. While I would certainly have preferred to use precision ball bearings, the bronze bushing should prove adequate for initial experimental purposes. With the bushings pressed in place, the pivot rod mount is ready to accept the pivot rod. Keeping things as simple as possible, I decided to use a 1/4 inch by 5 inch stainless steel carriage bolt threaded full length as the pivot rod, as this would allow for ease of attachment and positioning of the pivoting stator components. The first of the components would be the control arm, which I made from a piece of flat aluminum stock. A 1/4 inch hole was drilled at one end to accommodate the pivot rod, and a smaller hole centered 1 inch from the pivot point was drilled for the linkage rod attachment screw. Next, a stator mount template was laid out on paper and the location of the stator magnet mounting holes in relation to the pivot point was marked. I decided to keep the mount wide throughout its length rather than narrowing it down at the pivot end as shown in the Mostat animation, as narrowing would have made it weaker at the pivot point. I then traced the outline of the template onto a sheet of 1/4 inch thick clear polycarbonate, which I cut out and drilled at the marked locations. This photo shows the stator magnet attached to the stator mount with the bottom side up. Next, the pivot rod is inserted through the barn's bushings, and the control arm and stator mount are attached as shown in this photo. The assembly could then be positioned at the side of the slider rail at a point where the pivot rod would be centered over the bike wheel rim and mounting holes drilled accordingly. Next, a measurement was taken for the most appropriate length of the linkage rod. I wanted to make the linkage rod as long as possible so as to keep it positioned closely parallel to the slider carriage during operation. Once the length was determined, I made up the linkage rod using the same 1/8 inch by 3/4 inch aluminum bar stock that I had used for the pivot rod control arm, and drilled the attachment holes to accept number 832 machine screws. Here you see the attachment method used for the completed assemblies. The stator mount has been removed in this photo to show the linkage rod attachment detail. When the assemblies are mounted to the slider rail, the linkage rod will be parallel to the carriage as shown in this next photo. You can see that the pivot mounting bar is attached to the slider rail bar with carriage bolts using an 11/16 inch offset. This is done to allow the carriage assembly to move freely without contacting the pivot rod. The large washers that sandwich the stator mount are stainless steel fender washers, which I chose for added stability. The stator magnet is now in full attraction to the rotor magnet group below it, and the slider carriage is at its full outward travel limit, which allows for attachment of the outward channel stop to complete the installation. This view shows the outward channel stop mounted in position, and the slider carriage has been moved to its inward stop position. This reveals that the gap shown between the outward stop pair, which represents full carriage travel distance between stops, is 11 millimeters or 7/16 of an inch. This is even less than the original estimate of 1/2 to 5/8 inch because the linkage pin of the stator control arm swings in an arc, while the slider carriage moves in a straight line, and therefore less movement is required from the carriage than the control arm. Now I will show the 3 positions of the pivoting stator magnet over the bike wheel rim. At first position, the carriage is at its inward stop and the stator north pole is in attraction to a south-facing up rotor magnet group. At second position, the carriage is in mid-transition and the stator is at a null point between rotor magnet groups. Keep in mind that while the stator has now moved through 5/8 or 20/32 inch of arc swing, the required carriage travel was only 7/32 of an inch, or roughly 1/3 the amount. At the third position, the carriage is at its outward stop and the stator south pole is in attraction to a north-facing up rotor magnet group. In constant motion, the pivoting stator would move back and forth like this. I see that we are approaching the time limit for this video, so I will not be able to demonstrate the new mechanisms in full video motion today, but will definitely do so in my next video installment. Until then, thank you for watching and happy magnetic attractions to you.